Yeah,
sorry.
good. I think it's recording now.
Okay. Thank you anyway. Yesterday we will be talking about how to combine two forces together. So there are two methods. One is geometry method. If you know the angle, you know the magnitude, we can use law of sine and law of cosines to find out the total magnitude of two forces together. And with this information, we can also find the angle of the resultant force of the combination of two forces. However, there is a major drawback of using geometry method, which is it can only apply to combine two forces. If you need to have more than two forces, the only way you can do is combine two first, then you add the third force to the resultant of the previous two forces. And after doing that, you add another force. So this method can be tedious. But if you know law of sines, law of cosines, you can certainly do it. The other way is vector representation. So instead of using magnitude and angles, we can decouple the force equals to the combinations of x direction and y directions. Keep in mind, the vector for this force is going to be I as x direction, j as in y direction. So if I have a second force like this, I can easily decouple it into those two directions. So if I wanna add two forces together, that can be straightforward, which is x plus x, y plus y. If you need to add z direction, you simply add another component over here. I is x, j is y, so for sure z is going to be k. Okay, that is how we represent the force in 2 dimensions or 3 dimensions. So when you see this information, you might wonder, sometimes you might need to know the magnitude of this force. How are you going to acquire that? So if you need to know the force, sometimes we use norm. You might see this in some textbook. You might see it's just a number like this, okay? It's going to be the square root of the square value of x and y added together. Then take the square root of this one, then you get the information. How do we find the direction? Well, based on the triangular relationship, this is certainly going to be my fx. This is going to be my fy. If we say this one is my theta of f, tangent theta f equals to what? Y over x. Everybody with me? Understand how I get this equation? So if I want to know the direction, what do I get? Theta f equals to what? Tangent or inverse tangent of this value, then you get the angle. Over here, you need to be careful because based on your calculator, the unit of this one can be different. It can be radians, it can be degree. Based on the setup of your calculator, you need to find out it accordingly. Because a lot of time you press that as a radius, but when you answer the problem, you say it's degree. That's totally different. So with that said, let's know the conversion between radians and degree a little. So if you say it's pi, how many degrees are we talking about here? 180. So 2 pi is what? 360 degrees. So now, I have said the degree. If I want to convert that into radians, how am I going to do it? I'm going to divide this number by 180 degrees. Multiplied by what? 5. That becomes radians. If I'm giving you something which is gamma radians, I want to convert that in degrees. Then what do? I need to divide this number by, just like when this part is divided by the total degree of half circle. This one needs to be divided by pi. Multiplied by what? 180 over here. Then the unit becomes degree. Is that clear? Everybody understand what I'm talking about? Is that straightforward? Okay, this is very essential conversion you guys need to know, because a lot of time you guys will make mistake. The top one is 9.81. You multiply English unit by 9.81. That is ranked as number 1 in the exam. Converting degree into radians or radians to degree, you make it wrong. That's the second.